Greetings, this is Artie from Artifact Electronics. This is part 2 of our Commodore PET repair. Brief recap of last time was that we got the machine, the screen didn't light up, it made a chirping sound, but we couldn't see anything. Tried a few things, went into a few of the wrong alleys and then trying to figure out what was wrong with it. Finally zeroed in on the problem, even though the final diagnosis was based on a guess. An educated guess, yet it was a guess. Replaced the memory chip and the machine came back on. It's back on. I have had this thing running for 24 hours. It's still responsive. Well, somewhat responsive. We do have one good key on here. That still works. But if you remember, the keyboard was mostly dysfunctional or unfunctional. So what we're going to do this time is take out the keyboard and see if we can figure out what's wrong with it. You might remember that the keyboard physically was quite wobbly. It wasn't just not specific keys up, but the whole keyboard assembly seemed to pivot up and down. And after opening it up, I found the reason for that is, if you look closely, there are a total of 12 mounting points here. And of course the corresponding holes on the keyboard to screw it in, and it should be rock solid. Well, all we had was 2 screws in there holding it in. So somebody worked on it and threw their hands in the air and lost the screws and just kind of tightened things enough to pass it on to the next sucker, who's speaking to you right now. But let's see if we can find out why things aren't working. It's not that hard to set up a test environment because there's the keyboard, and here's the keyboard connector, which just barely reaches, but we can plug that in and mess around with the keyboard to see why things are being uncooperative. It's your general, pretty typical keyboard setup, lots of little screws holding the PCB to the back. Some soldered wires here, and in this case all it is, it's the caps lock key, which is a latching key. So let's go and take this part off and see what we can get. A good number of screws later, we can now lift off the PCB. Oh, and we also have to desolder these 2 wires from the shift lock, or what do they call it? Yeah, shift lock. So this PCB lifts off, and what we see inside is our standard fare of plungers with carbon contacts on the end, and of course our PCB, pretty standard fare, gold-plated connectors that the plungers press upon, complete a circuit, and make things work. So there are marks on here. Oh, I didn't show you. The best part is, if I can get this to show up, this sticker here says cleaned 388. So in March of 1988 somebody cleaned this keyboard, so it started having problems early on. You can see some scratch marks on here where I'm afraid somebody used some abrasive to just sand down these contacts. You should never ever do that, especially not with things that are plated. And because it's pretty easy to rub all of the plating off, and then you're in deep doo-doo. But what I'm going to do is first clean this one with alcohol. Hook it up and hook it up to the connector in the computer, and then see that if we're manually putting a conductive element on top of each of these switches, if we can get the keys to function. Here's our test setup. Nothing to worry about here because the other side of the PCB has nothing conductive on it, including the connector. So we can safely turn this on. And first let's use this plunger that showed us a 200 ohm resistance, if that does anything. Doesn't look like it. Nope, this is for all intents and purposes non-conductive. So let's use a bit of a conductive foil here. What's that? What is that key supposed to do? It says inst delay. Oh, insert and delay. I don't know why it jumped all the way over there. This is cursor control. Okay, this is up, down. I mean, you have to use the shift key. But we're just checking to see if the keys register. And this is the clear home key. We continue with a slash 9, 8, 7, 6, no, asterisk 6, 5, 4, and I'm going to go through and test every single key with this thing and make sure that the electronics are working and that the PCB itself is sound. So I even tried cleaning the carbon nubs on the end of the plungers again. Made no difference. So I did something some of you may have seen in a previous episode. I think it was a Radio Shack keyboard where I fixed this by basically punching a disc out of the metallic tape material, which is self-sticking, of course, using a hole punch like this, and then with tweezers transferred the resulting disc on top of the carbon contact. And then if we try that out, well, it should work because we just tried it, and it's got to be centered. It's a bit sensitive towards being centered right, but once it's in the keyboard frame, that shouldn't be a problem. Interesting. That one, oh, that one doesn't want to work because the disc fell off. So what I got to do is clean all of these very well with alcohol, because whatever's on there may not be giving good adhesion to the metal disc. Clean it with isopropyl, let it dry for a while, and then cut a boatload of discs or punch a boatload of discs and put them on there and see if that helps us any. Unfortunately, that one turned out to be a fail, even though it worked on a Radio Shack keyboard. The problem is, it does work because we got a nice conductive surface on top of the carbon contacts. But the problem is that with these particular carbon contacts, the discs, the adhesive on the disc doesn't want to stick to them properly. You can see there's a bunch of them missing here. I had pretty much done them all, but then as a test I blew compressed air, just a little blast on the keyboard to see how well they adhered, and a few of them flew off. So to me that means that the adhesive and the carbon contacts aren't getting along, and that in the PET keyboard this approach will probably not work. Plan B would be to use something I have used successfully before, and that is this, it's a rear window defogger repair, and basically what it is it's conductive glue, or also called wire glue, dyed to the same color as the little resistive strips on your rear automotive window heater are. And when those get scratched by cargo or whatever, they just they sell you a little kit with a template in here that you lay over the wire, and then you just paint it in with this stuff, which is the wire glue. I did this on a keyboard, on a musical keyboard that had the same kind of carbon contacts as that one, and it worked really well, and the keyboard is still working after a year. So I was going to use the same thing. Makes things a lot easier. Just take the bottle and paint all of the carbon contacts with that. The problem is there's very little left in this bottle, not nearly enough to do the whole keyboard. And after a trip to the auto parts store, they told me that they no longer carry this. So you'll probably get it online, but I'm a bit impatient, so I'm going to see if there's anything else that I could try out to fix this. I did make a little test patch where I put some of the wire glue on a business card and measured it, and has really good conductivity. But I also noticed that this is a single coat of paint. It got pierced very easily. You probably can't see that, but it got pierced very easily by the probes from the multimeter. And then I read the instructions, and it said you need at least 3 coats. Well, I still don't have enough of that. An alternative to this, of course, is to get on eBay and just buy a little tub of wire adhesive, or whatever it's called, and then paint all of these guys with that. But not before I try something else, and that is, I took a piece of regular tin foil, heavy duty, and punched out some discs. Of course, these have no adhesive on them, and they're kind of easier to make because you just punch out a disc and it kind of falls out. Well, half of them fall on the floor and you never find them again. But using the same approach that we originally used, and if we need some way of adhesive to make these discs stick permanently to the carbon contacts over here. And the only thing close to that I could find is liquid electrical tape, which is essentially, this is glue, or, rubberized glue, I would say. So what I'm going to try to do is punch out a few of these discs and then put a dot of this glue on top of the carbon contact and transfer a disc, a pre-punched disc on top of it, and see if that holds. I mean, we know that it's going to work. Conductivity of tinfoil is very good. And so right now the problem is not so much how do we get conductivity back, but how do we keep the conductive parts from not falling off of the carbon contacts. So let me give this a try. Would you believe that one failed too? The liquid electrical tape stuck to the little discs just fine, but it would not stick to the old carbon contacts. So these things, I don't know what transformation they've gone through, but they've become totally non-porous and non-conductive. So the problem now boils down to is kind of similar to what we had before or currently, that what adhesive to use to get the discs to stick on top of this. And the solution turned out to be this super glue. Just a little dot, a bead in the middle of the carbon contact, and then I put on the discs and they stayed there forever. I did use gel type, because the watery type tends to run all over the place, and I didn't want it to be on all of the keys, but this worked. All the discs stuck, and everything seemed okay for a while, but then I saw some intermittent functionality on the keyboard, where when you played with the keyboard connector here, they would come and go. The fault was of the connector that plugs into the keyboard, because the fingers inside are corroded, and I cleaned those, and also the part where you press fit the wire into didn't really work very well, because I stripped all the wires and refit them in here, and that didn't make a difference. So finally I soldered all the wires into the connector, hardwired this thing, and that seems to fix the problem, finally. So I'm going to put the keyboard back in now and see if we can type something in. So here's what it looks like. Keyboard's installed with all of the screws in place. And here's the direct connection, of course. I would have preferred to put an edge connector on here, but I didn't have one that was, 18 pins wide. And I mean, the solution works just fine. And it's reversible, because these were there are holes in the PCB that I just stuck the wires through and soldered them. And if I find a edge connector, an appropriate edge connector for this, I can always desolder these wires, put them in the edge connector, and use the edge connector over here. So we should finally be all set to go. So let's see. Let's see now. Okay. I can't get used to the numbers being over here. I keep trying to hit shift and use the upper row. And there you go. Now, one thing I can see immediately, it looks like the tube is rotated this way slightly. See, this line doesn't match up. I mean, the margin doesn't match up with the edge of this. So let's go ahead and fix that while we're at it. And the way we do that is, of course, take the back cover off, and see there is a clamp over here that keeps the neck from rotating within the tube. So what we're going to do is open that, loosen the clamp screw, and then basically, while looking at the screen, let's see if I can show that. And then we just grab a plastic part and rotate it. And I think, what do you think? Is that straight? Yeah, the pictures, it now looks like the top may be off, but the side's okay. Yeah, the picture isn't perfectly rectangular. It seems to be a little bit squished on this side. But for now, that's going to do. Of course, when there's nothing on the screen you can't see. So yeah, picture's slightly squished on this side. But again, we'll tool around, or I'll tool around with the monitor, and it needs to be recapped. So I'm going to make a list of caps that's necessary and see if that fixes the problem. Well, that concludes the repair of this guy. He's working now, or she's working now, and the restoration part is basically, it's going to need some cleanup. I cleaned it up a bit, but there's still dust and dirt inside here. There's some rust in the monitor casing on the inside that needs to be attended to. And of course, recapping the monitor itself so we get the picture to be more of a rectangle. And some other stuff, just general restoration tips. When I first opened this thing up, the cage or the case that contains the crystal and the divide down circuitry, this was completely rusted, and I mean, it was just a solid piece of rust. And in this case, vinegar did wonders, because I basically bathed this in vinegar overnight and then used fine steel wool on it. I mean, I could paint it to make it perfect, but this looks more authentic and doesn't have the rust on it anymore. But other than that, there really isn't that much more to be done with this. So here it is, another piece of computing history brought back to life. And again, a lot of the stuff we did would probably apply to other repairs too. So please leave me a thumbs up if you feel, of course, that this was worth it. Make sure to subscribe and leave me comments. Let me know about your own experiences with machines, either exactly like this or machines that, older 8-bit machines where you found some special trick on how to get things to work again or how to clean them up. And I could incorporate those into future repairs or restorations of these kinds of computers. Happy computing!